Hey everyone, and welcome to Chapter 6 on factoring. Before we get into factoring proper, I would like to talk a little bit about what the greatest common factor means, because we're going to be hearing that term a lot. So remember that when we multiply two numbers together, the individual parts you're multiplying together are referred to as the factors, or also as the divisors. So here we have two expressions being multiplied together. The first one is just numbers, 5 times 8 equals 40. The second one is the product of two polynomials. So the individual parts are the factors. You can see those in orange and green. The products, or the answers, are highlighted by this purple. So that's what factors are. The noun form of factor refers to exactly what I said, the individual multiplicands in a product. It can also specifically refer to integer factors of a given integer. But what we want to do now is focus on factor as a verb. So what does that mean? Factoring as a verb is to separate a product into factors. Right, so if we have two terms being multiplied together, A times B equals C, when I go from the left-hand side to the right-hand side, I am multiplying the two terms. When I start with C and I split it into factors, I am factoring. So if I start on the right-hand side and move to the left, that is factoring. Now a little bit about greatest common factor. So the greatest common factor of two or more integers is the greatest positive integer that is a factor of each integer. So what we do is we look at an integer and we break it into its integer factors. And when we have two of them, we can compare which ones they have in common. The GCF, greatest common factor, is the greatest of all of those. So as an example, we want to find the GCF of 24 and 128. We're going to have to make a list of the factors of 24. We're going to have to make a list of the factors of 24. So I know 1 and 24. 2 times 12 gives me 24. 3 times 8 gives me 24. And 4 times 6. For 128, let's see. I know 1 and 128. I know 2 and 64. 3 doesn't go into 128. 4 and 32. 6. 5 and 6 don't go in. 7 doesn't. 8 goes in 16 times. And I think that's it. So of the factors that they have in common, we see that 8 looks to be the greatest. The common factors would be 1, 2, and 4, and 8. The greatest common factor would be 8. That's how GCF works for integers. For polynomials, it works kind of the same way. The greatest and greatest common factor for polynomials is referring to something different than the greatest and greatest common factor for integers. So the greatest common factor of two or more polynomials is the polynomial that has the greatest degree among all the common polynomial factors. So let's start small, and we want to look at the greatest common factor of all of these four monomials. Again, I want to be looking for the polynomial with the greatest degree among all the common polynomial factors. So how do we figure that out? Well, here's what we're going to do. We're going to list each of the monomials, and we're going to break it into its prime factors. So for the coefficients, that would just be the prime factorization of whatever the coefficient is. So for 3, since 3 is prime, obviously, it's just 3. And then times x times x times x. Second one, we have 6x squared. And this is 2 times 3 times x times x. For 9x to the fourth, we have 3 times 3 times x times x times x times x. And 12x squared, we have 2 times 2 times 3 times x times x. And now what I want to do is find the greatest common factor among those. And since we've split it up into these prime factors, it's pretty easy. We look at all of the primes that are in common between the 4 monomials. So they all have 1, 3 in common. The other ones don't. There aren't any other numbers that are common to all 4. There's also one x in common and another x in common, which leads us to the GCF of these 4 monomials is 3 times x times x, or 3x squared. So as long as you feel comfortable factoring numbers into primes, this is pretty straightforward. Let's look at another example. I have now 25m to the fourth. This would be 5 times 5 times m times m times m times m. Oops. 35m cubed. That would be 5 times 7 times m times m times m. And 20m to the 6. That would be 2 times 2 times 5 times m times m times m times m times m. Now let's look at what they got in common. So between all 3, I have one factor of 5 that's common. I have m in common. I can get another 3 m's in common. And actually, I can even do this one more time. So the GCF is 5 times m times m times m, or 5m cubed. So that's the GCF. Don't worry if you're feeling a little bit shaky on it, because we're going to be doing lots of this over the course of the chapter. So next up, we're going to actually start factoring bigger polynomials. So look forward to it.